Hello, everybody, and welcome to our March first live stream of March. This is our storage Q&A live stream. We have instead of one of our product Q&As or one of our general AMAs, we have the wonderfully amazing JM here to talk about all things storage, and a special guest star Harold to talk about some shiny new thing that they've been working on as well. Um, so yeah, I'll let the guys say hi real quick, and we'll kind of get started because we have a lot of questions already piled up thanks to Reddit and Keybase. So it's gonna be a fun one, I think.
Yeah, that's exciting. Thanks, guys. We wanted to just take some time today. We didn't forget about the farming community. I know there's been all the buzz about all the new product features we have, like cats and DeFi and offers. But we still are investing in plotting and farming development, and we kind of want to give you guys an update of what we're doing here. So, and feel any questions today are okay. Anything, we just kind of want to keep it towards storage, plotting, and farming. Industry stuff is totally fine too. Just, yeah, feel free to ask questions in the Q&A. We'll get to them.
Hey guys, this is Harold Brenes. I'm the author of Bladebit, and now I joined Chia back in September as an engineer.
Cool. All right, so let's kind of get started here. As usual, folks, like all of our Q&As and our AMAs, please don't put your questions in the chat. We will most likely miss them. The Zoom does have a delightful Q&A function, so please use that. Put your questions in the question and answer box. We will find them and we will try to answer them. If you are watching us on the YouTube live stream, words hard. If you're watching us on the YouTube live stream, we will maybe see your questions in chat, but there's a good chance we'll miss them. But we will do our best to try to see those. We also have some questions that came in on Reddit over the course of the week leading up to this, so we will definitely pull some of those questions in as well. But if you're going to ask a question right now live, definitely use the Q&A box on Zoom. Don't use the chat. With that said, we'll kind of get started here. So let's start off with, I've got some fun ones from Reddit while we wait for folks to put stuff in the Q&A here. I got some things that's kind of been sitting around here this week that were kind of some good ones. Let's see where we can start here. Let's start with a really easy, fun one for JM. Have you been helping any vendors with more Chia optimized hardware that we might see coming out in the future?
Yeah, if you saw, we released actually on the Chia docs. Eventually, we're going to have a storage section there where we have plotting and farming and all the other wikis. It's on the to-do list I have to take all the stuff we had in the old wiki and like move it over to the docs all buttoned up. But we have this thing over there called the farming workload analysis, which basically describes kind of the IO characteristics and frequency of access and number of disk IOPS and bandwidth and everything for the drive. All the hard drive guys like Western Digital and Seagate and everything, they understand this very well. They've done all their internal analysis. They have bus traces. They have all this stuff. They know exactly what it would take to build the best Chia drive possible. So one of the things that we mentioned was that blog post we recently did on host managed SMR for Chia farming. That's going to be an easy one where you can get 20% extra capacity for the same cost, but you have to do some stuff in the software, like use zone aware file systems to basically be able to format the drives to get that extra capacity. So that's one thing. Like, they don't usually sell those types of drives to consumers just because it's previously thought that no consumers had any use case that was SMR friendly for this host managed SMR. So that's one thing. The hard drive guys can make these hard drives that are kind of these bigger capacities, low power. That's not dissimilar from what like Facebook or Microsoft or other guys want for archive storage. So that's no big deal. Really, it's just opening that up, finding some way to sell those in the channel to people that want them for farming, and that's awesome. So people are going to have 24 to 26 terabyte disks at the end of this year, using SMR drives. So that's awesome. For the plotting, it's a little tricky because unfortunately the plotting changed pretty fast. Right? I remember we did that Phison presentation last year, and they developed this Chia optimized plotting SSD that basically used SLC for high endurance and high sustained bandwidth. Which was really good at kind of small capacities, but the capacities they made, like the 1 and 2 terabytes that some of the partners made, were a little bit too expensive for most Chia plotters, right? People weren't going to spend $600 or $1,200 on a plotting drive, when there wasn't that like huge craze for plotting, like we saw like right after mainnet launch. So I am working with them on getting something in that like lower price point, because that $100 to $200 range right now, a used data center SSD is still a really good pick, but like there's not any really good M.2s for that price range. You can buy consumer M.2 that has good performance for plotting, but not enough endurance. that sucks. You don't want to wear out your drive after plotting 100 terabytes of hard drive. So we're still working with them. All the vendors we talk to, again, understand this super completely. We're just trying to look at like, what is the size? You have to get the price points right, and figure out how do we get those to market. So
Cool. Okay. Also, someone's getting a lot of Discord notifications. Just saying, we hear that. So we actually have a question that it was aimed at you, JM, on Reddit, but I don't think people didn't know Harold was going to be here, so I don't think they do realize it'd be a far better question for him. But for both of you guys, I'll read it as it was written, even though it's probably more applicable to Harold. JM, you mentioned before that BladeBit will be getting an option to partially use an SSD for users with less than 416 gigs of RAM available. Mad Max leaves some performance on the table, and the use of a RAM disk is not optimal. Have you tested this new BladeBit feature, and is there any idea on an ETA when we might be able to see it?
all right, well, we're going to just get the big announcement out of the way here right in the beginning. So Harold, I'll leave it over to you, but Harold has been working on a new project called BladeBit Disk, which is the new evolution of BladeBit that is able to use disks more IO friendly, has native caching to use DRAM more effectively. But I'll let him. He's got a couple slides. Harold, if you want to pull up the introduction.
Yeah, sure.
Talk a little bit about plotting. I've been testing some of his alpha builds here on some of my systems. It's been fun.
Yeah, so we've been real busy for the past few months, and it's true we have been working on a BladeBit version that's using disk and potentially a hybrid version that has much lower RAM usage, but can still do everything in RAM pretty much. But let's get share a little bit of slides we have prepared. You see if you guys can see my slides. Good. All right. Yeah, so before we get into the BladeBit stuff, I just want to share a little bit about how the plotting process actually happens and what's in the plot file itself, just so we can understand what the changes we're making or the benefits we're getting when with this new version of BladeBit. So, and this is a practical overview of how the plotting process works. It's not an analytical one or a mathematical one. For that, you can read the proof of space construction document that you can find in the ChiaPOS repository, which goes really into depth about everything plotting. We'll take a quick bird's eye view of the process, and we'll only cover phase one without going into details of the implementation. So let's get started. For the purpose of this example, we'll use a k-value of 32, but you can extrapolate everything you learn here for any k-value. So everything begins with a random plot ID of 256 bits or 32 bytes. And this is generated via a secure random function, which is usually just provided by the host OS itself. We use the plot ID as a seed for ChaCha cipher, which is used as a pseudo-random number generator, and we'll use that to generate 2 to the k entries for the first table. So we proceed to generate 2 to the k random values for the first table, and these are values, each value of k plus 6 bits each. So when you have k32, that's going to be 38 bits each y value, we'll call it. So each we'll call it f1 in the first table, but also y in the rest of the table. So as you can see there in the graphic, the y value has filled the whole table with random numbers. And then we also, along with that y value, store the index of that y value that got generated, and we call that the x value. And both of those values, y and x, correspond to one entry in the table in the first table. The rest of phase one is a repeated process. So we'll work with 2 tables at a time, the L table or left table, and the right table or right table, the L table being the table we have just generated all the entries for, and the R table is the table we're about to fill. We'll do this sequentially from tables 1 through 7, with 7 varying ever so slightly, just as table 1 varies a little bit. Note that the second table has 3 slots or 3 components as opposed to 2 slots in the first table, and we'll get into that shortly. So we start this series of steps by sorting the entries on the L table on the Y value. So as you can see, each Y value now shows is shown in ascending form from the lowest to the highest value generated. And with that, you can see the X values are now found out of order. So they still correspond to the index it was originally, but now they have obviously the sort in a different order. After the entries are sorted, we perform a matching step in which we take pairs of Y values found in the L table and process those through a matching function, which will generate a new entry on the R table. This R table entry is saved as a back pointer entry, which has 2 pointers in it. So one entry has 2 pointers, and we'll call those the left pointer and the right pointer. You can see it, you pointed out here. So the left side of the entry before the comma, that'll be the left pointer, and this one will be the right pointer, but only one entry. And again, those point back to the entries that generated. So after you perform the matching on this table, you'll take 2 values from there that match to Y values, and you'll create a new entry and point back to those values that generated that one. And this matching phase can actually potentially produce more than 2 to the K, 2 to the K values or entries, or perhaps even less than that. In the case that it produces more than 2 to the K entries, some implementations like BladeBit, and I believe MatMax also truncate those entries up to 2 to the K. And you may have heard Bram talked about this before, that these implementations drop those entries, and that's what he's talking about. ChiaPOS, the reference implementation, does not drop any entries. Then after we generated those back pointers, so we perform all the matching with and generate all the back pointers on the right table. We take from each back pointer, we'll grab the Y value pointed by the left side, the left pointer. So this top one, in this case, in this example, we're pointing to the first, or the 0 index, which is the first entry in the left table. In this case, 45. We'll pull that Y value, and then we'll pull the metadata value, which is in table 1, it corresponds to X, for both sides of the pointer. So the left and the right, we'll grab those values, and we'll pack them together and then process those 3 values through Blake3, which is a cryptographic hash function, and we extract out of those values two new values, which are the new Y and the metadata value that we'll place in the R table corresponding to the back pointer, which we just used. So the whole entry will look like this at the end of that process. So from that back pointer, we process that through Blake3, and now we have a new Y value and a new metadata value. The metadata value and the Y value are ephemeral. They're not actually stored with the plot itself. They're only used for generation. And we'll see a little bit of, there's one Y value that gets stored in the 7th table, and we'll see that shortly. So we get to table 7, since this has no R table, it does not produce any metadata, but only the Y value, which in this case we'll call F7, and this is what gets stored in the, when we exclude the actual, the 6 bits that we use to generate the other ones, we take that value and store it in the 7th table. But no metadata, as you can see.
This is a good time to pause for 1 second on that.
Sure.
And so there was a lot of questions on, we had one question from our Chinese community on, like, can proofs of space be faked? There's some, rumors and people in China like trying to like fake a K equals 32 to make it some other higher K value. And if you can see, if you just learned something from these table generation, the proof of space construction in Chia is actually one of these big breakthroughs, which we create a proof of space that is like immune to Hellman attacks. You can Hellman attack the first table which is you can put more compute in to basically generate a better proof in the first table. But all that phase two and the rest of the tables can't be, depend on that first table. So there's one really important thing, which is the plotting is really hard to make the proofs of space secure and so that they cannot be faked. The next thing is that nice, neat table 7 entries. When you get a challenge, that's the only table you have to start to check. And it's very quick and efficient to do a proof of space lookup. That's why farming is so easy on the drives. There's very little IO on the drive because the proofs of space are generated and sorted in a way where you don't have to read all the data when you get a challenge. You just have to read a few bytes.
Yep. Thanks, JM. And I make a note of that here at the end. And this is basically the final output you get after phase 1, which these are all your tables. And as we mentioned previously, no Y values or metadata stored in any of them except for the 7th one, which, like JM just said, this is what actually gets checked whenever you get a challenge. So it takes a portion of that of the challenge and matches it against the F7 values in all your plot files. If it finds one, it's going to go and trace all the back pointers all the way back to the first table and grab 64x values, and that's what makes up a proof. So keep this moving. And that basically was just a little preface to share a little bit of information about the new BladeBit disk plotter, and just so you can understand how it actually, how the plot actually works, so you can, I guess, understand a little bit more about the benefits we're adding to this version. So stuff we have this plotter now. We have a high performance in-house plotter that we can actually get to own and own the design choices and the direction we want to take for it, and implement whatever we or the users need. And we can also make any changes we might need given any plot format changes in the future. As mentioned before, this plotter will not, as mentioned before, the other version of BladeBit, and I believe MatMax also truncate entries. So whenever you get more than 2 to the K entries in the matching step, we drop those. This one will not drop any entries. We have no random IO in this version. So this means that all your reads and writes will be sequential, and we'll be able to hit the top speeds advertised and when we're writing and reading from disk. This also means we'll have lower write amplification, so your disk will not degrade as easily, and JM can speak a little bit to that if you'd like to know what that means. He's the expert on that. So we also avoid blocking IO. We basically do all the IO in the background. This one is, I believe, most people are going to be pretty happy about this one. So you can actually use, and this goes to the question that was asked earlier. You can just specify how much RAM you want to use in lieu of disk space. So you have an in-process memory cache, so a RAM cache that you can use instead of setting up a RAM disk. So you don't have to set up a RAM disk, and you'll have faster access to that data because it doesn't go through any system call function for reading and writing. It's just right there. We just allocate it right there in the process and get to use it. It does go to any backend storage if it's not enough. And we also get more fine-grained access to that. We decide what to do with that memory. It's not up to the OS.
Yeah, so yeah, just to recap, this BladeBit disk is going to work on any type of system with either low RAM, or if there's a lot of systems, people that have 64 gigabytes or 128 gigabytes that aren't making very good use of that RAM, and they have to use third-party tools to basically create RAM cache and stuff. Well, when you create in MatMax, when you create the temp2 and you do that on a TempFS, like a RAM disk, you're treating that memory like storage. You're doing large block data, in MatMax, the block size, especially for SSDs, is 128K writes, where you get much better performance if you're doing native memory byte addressable reads and writes. So BladeBit it's actually doing these in C++. It's not treating that memory like disk per se, but it's actually using the advantage of memory. So this is going to be awesome. So it's going to be not as clean cut of oh, here's the temp space and here's the amount of RAM you need. It's going to work differently in a bunch of different systems and kind of adapt to the performance of these different systems. And you mentioned with the sequential IO, it's going to be good for a lot of different types of disks. Obviously you're going to want a fast SSD that can do good sustained read and write bandwidth. That hasn't really changed from, what has been on, previous plotting, but it's going to take better use of that drive instead of like where Mad Max just kind of throws everything at the drive and says, hey, drive, figure it out. But this is going to do that much more ordered way. So it's a little bit nicer to the disk.
That's correct. We'll go through these other two real quick and then we'll wrap it up. You'll also be able to have the option to use direct IO or unbuffered. So there's some portions of plotting where you don't want to actually make use of that because you're writing to some files that will not get used to, for example, the next phase. So don't have quick access, don't need to access them till later. So it's better to use direct IO. You also have really low RAM requirements, and this is fixed. So if you select the bucket size, that's a fixed RAM memory requirement, and the buffers are allocated once and reused. So if you're doing sequential plotting, you won't have to reallocate or anything. It'll just keep reusing those buffers. Right now, we believe it's going to be about 1.5 to 2 gigs of RAM, the lower end, so the maximum bucket size, to 6 to 8 gigs. And I have a little diagram here about the technical specifications of BladeBit, but we can share that later. It gets a little bit more technical for the technically minded among you. So with that, thank you.
Cool. And then one of the questions that we had immediately asked as you're going through this is when is this going to be available to everyone?
I'm holding the fire to Harold to get us an alpha this month, and then we'll have like kind of probably a public beta next month with some more, meaning that, I mean, it's already open source on GitHub, but like don't run it yet. Like we'll tell you like when it's ready to run, we'll say here's the commands to run, here's all the stuff to tune, and we'll give you a little blog post and some guidance on like what to run. But yeah, the code's up there if people want to peek at it, but it won't probably make sense to most people unless you're doing development. So
all right, cool, awesome stuff. Very awesome stuff. So going back into some of the Q&A stuff in the Zoom call here, we got some stuff populating in here now. JM, do you have any updates regarding the Circular Drive initiative?
We do, yeah. So we've been meeting bi-weekly with a broad set of founding members, and I've been working on the nonprofit organization setup. So unfortunately, most of my time for CDI in the last couple of weeks has been spent on like legal stuff. Like we're setting up this nonprofit, and it's like, okay, well, how many board members do you want? Like, what are the voting rights? Like, so, that's not. But we are spending time actually solving the problem where. So one of the big things, I attend this IEEE work group that talks. There's a new spec called. It's like a spec called P2883, which is the spec for media sanitization of like how do you securely wipe a drive at the end of its life. And so I've been working on developing that with the IEEE group and making sure that they understand like, please do not like destroy drives at the end of the use. And here's how to properly erase the data on the drive cryptographically and securely so we can, enable stuff like CDI. So we have lots of interest from a couple of big hyperscalers and the drive vendors. I can't announce exactly the members' names yet because we're in the middle of signing all these legal agreements. So, but I can't wait till it'll be hopefully just a few months before there's actually a real CDI organization that exists as a nonprofit, and we'll start releasing lots of collaterals and videos and all the good stuff we want to do. But in the short term, some of the drive vendors already have programs for recertified drives that they've had. So I don't know if you saw that, like Seagate released a video about their take-back program that they have for circularity, that they're basically going to work with customers. When the customers use the drive, they can return them at the end of the life cycle, and Seagate will make sure they're sanitized correctly and then can resell those or recertify them. But they've hooked us up with a couple of the Seagate resellers of recertified drives. So they have recertified drives, which have a warranty, that are basically drives that are good. They like are pretty much brand new. People return a drive, they'll recertify it, they'll just like clear it out, and they'll put a label on it and give you a 3-year warranty. And then there's another class of drives which they call white label, which basically come with no warranty, but they're basically like a new drive, but there's maybe like one thing that was messed up, and then they reset it and everything's great. But they don't want to sell that as a new drive, so they sell it as this white label drive that doesn't have the logo on it. And so if people want to buy those in like 100 counts plus, we can hook people up so people can already get these used drives for a much lower cost. So they've given us some. So in the short term, if people want, and we're trying to figure out a way to like get these to the farming community, because it's not really like these distributors that sell these like used drives. They don't sell them in like 1 count or 2 count. They sell them at 100 count or 1,000 count. So we were thinking about doing like some kind of like community buy or something fun where we can maybe like pool together to get people that are really into Chia farming some cheap drives. But no, everybody again super excited about CDI. We've got lots of great participation from hard drive vendors, SSD vendors, hyperscalers. We are working on it very hard.
Cool, awesome. I am familiar with those white label drives. I even have quite a many of them in my own farm. Every time I shuck something, I'm like, oh, it's a white label. Okay, cool. So something that has been often debated in the community a lot, the nuanced details of back and forth has been asked. Someone's asked, can we clear up once and for all the debate over a K33 versus a K32? Because plot files are slightly different sizes and they aren't exactly the exact same size every time. Are the number of proofs in a plot proportional to the file size or to the K size? Does a K33 always have, for example, like 2.06 times more proofs than a K32, or is it just 2 times more, or can it vary a little bit? Like, are they always the exact same multiplying factor per K, or is there a variation between them?
Yeah, so I'll answer that. They basically are proportional. The thing is, they'll vary slightly because you don't know how many entries a particular ID or plot ID, right, will actually generate. So they're proportional. You don't have to, if you K32, K33, they're proportional to the size. They'll vary slightly because depending, again, what I mentioned, right now, the RAM version will actually use a little bit extra space because it uses direct IO, so it has to be aligned, block aligned. But otherwise, yeah, you don't have to worry about that. They're proportional in size.
Yeah, and so I think it's funny. I actually had Harold calculate this for me. I'm like, so he has a little spreadsheet that calculates like the size of table 1. I think there's like 4.2 something or maybe 4.6 billion proofs in a K equals 32 plot. So, when you're doing these proof quality checks and it tests 100 or 20, like there's billions of proofs in each plot. And so when the part that people get confused about is if you have a K equals 33, it has one plot ID, just like a K equals 32. So when the filter comes, it has a 1 in 512 chance of getting past the filter, the exact same as a K equals 32. Now, if it gets past the filter, now you have a little bit more than 2x the amount of proofs to go to the filter. So really your chance of winning is just proportional to the amount of capacity you have farming, whether that's K equals 32, K equals 33. Personally, I have mostly K equals 32 because I use a lot of blade bit plotting, and it's the most efficient as far as the fastest time to generate and lowest energy to generate. So some people like plotting higher K values. There is a value of reducing the disk IO because every time you increase the K size, now you've by a factor of 2, reduce the amount of IO on that drive for farming, because it's going to get accessed exactly the same amount of time as a K equals 32 from the plot filter. But the IO is already so low for farming, like that it's like, reducing it by a factor of 2, you go from like, whatever, like 4 kilobytes a second to 3 or something, it's really not a big deal. So, but yeah, there's also some people plot K equals 32 because they like to perfectly utilize the disk to 100%. I find with a K equals 32, I can fill up a 16 terabyte drive, basically to 100%. There's like a few, maybe 800 megabytes left over. On an 18 terabyte drive, it's like 20 gigs left over if you fill it up with K equals 32. So it's not a big deal to me, but other people get freaked out about that 20 gigabytes and they want to put plots on it. So
there are very intense conversations I've seen about how to, I plot until I can't fit another plot file. And I'm like, okay, the drive has like 30 gigs free, fine. The drive has like 95 gigs free, fine, whatever, right? And then there's people out there who they get, it reminds me of like the demo scene from like 25 years ago when you write those like tightly scripted demos that did the DirectX, like, visualizations are all using math. So you get like the biggest visualization down to the smallest file possible. Like they get aggressive about how to get that last gig out of there. If they find out I have like 70 gigs free in a drive, like I get lambasted for that. Some people really care about that optimization. Do we have any plans at any point to make plotting resumable for failed plottings?
I think at one point in time we had that on the plotting and farming roadmap. Just this is awesome. Actually, I'm going to be working a lot closer with the product team right now on defining some of the next wave plotting and farming features. And obviously, we have one-click farming. And, we've done some stuff like the Akash partnership to kind of get us more in a step towards that future where people, regardless of what kind of hardware they have, we can go figure it out. If they have good hardware for plotting, we'll plot with their hardware. If they don't, we'll figure out how to download plots. If they don't have good internet or good plotting hardware, then you're kind of stuck. We have to figure that out, right? We haven't figured that part out yet. That's where you want like a pre-plotted drive and other stuff that we're working with the storage vendors on. But anyways.
Okay. Harold's got one here. He tagged, you'd like to answer. So plot files have small variances in size. If this new no dropped entries feature on the updated BladeBit plotters used, does that increase the possible variances?
Like we mentioned earlier about the variance, it's due to many different factors, including, again, the plot ID. So I'm not exactly sure I understand the question that well, but they're definitely going to be larger because you don't drop any, and it's that very step by step. So go ahead.
Yeah, this exact problem. It hits a 16 terabyte drive. If you have a 16 terabyte drive and use K equals 32s that don't drop any entries, you can fit 146 on there. If you have a K equals 32 that drops just a few entries, it's just that little tiny bit of space, but you have 147 plots. That gives you that little extra like 1 gigabyte of space that you can fit one more plot on there. And so you can fit, I think, 147 plots on a 16 terabyte drive. I know because I have a whole lot of them. So but yeah, but it's really small. Like the actual plot size, the run-to-run variance of like, of a plot that is dropping entries or not, like the difference between them in just the size difference, you don't need to like plot until you get one that's like a good plot that's smaller, because the smaller size is going to be like just a few bytes. It's not.
Yeah. So. Yeah, it's negligible, and you can test it yourself. So the current no dropped entries, you can just make a plot with ChiaPOS, and you'll get no dropped entries. So you can use the same ID. So you can actually do this in BladeBit and ChiaPOS. You can specify the ID you want. So if you want, you can test it that way. Just make one in BladeBit, specify the ID, and then in ChiaPOS, same ID, you'll get one with dropped entries and one without. You can compare it that way.
Yeah, I'm actually kind of curious, Jim. What is your drive sizes? What is the drive size you have the most of? Is it 16s? Is that the one you have the most of?
I have a lot of 16s and 18s. Actually, it's funny. I'm rearranging some stuff in my colo, and I have like 30 final 8 terabyte drives that I'm going to be selling on Craigslist here in the next couple of weeks. I'm like just getting all the small drives out of my farm.
I love how you're like dismissively ruling out 8 terabyte drives as small drives.
So 8 terabytes are perfectly fine, but when you have like a JBOD and you have like very limited slots, I'm like, no.
Meanwhile, I'm thinking back to like junior year of high school when I scraped together $285 to go buy myself a 2.3 gigabyte drive to add to my system as a second hard drive.
Yeah, no, we'll be clear. I've done a ton of TCO analysis for Chia farming, and although 4 terabytes are still profitable, like I just would not recommend them. Like the power cost is so much greater than modern drives that are 18 or 20 terabytes. Like, you're just killing yourself. Like at some point, like, and again, I've been doing a ton of research also on Bitcoin mining profitability and TCO, and boy, every single model online for Bitcoin mining profitability is broken. They don't even calculate the cost of the hardware. Like any Chia farmer knows, like you actually have to buy the drives. Like you can't magically get drives for free and then farm off them. Like these Bitcoin people that are doing the calculations are like, yeah, there's no cost of the miners. It's just power costs. Like what? But anyways, I've done the analysis in 4 terabyte drives, although they remain profitable from the energy cost, even if you got them for like, $5 a terabyte or $6 a terabyte, like just my recommendation in general is just like 8 terabytes is kind of like the cutoff right now. Like I wouldn't farm on anything less than 8 terabytes. Yeah, I guess that personally, it's just because I only had like 20 of them. It's not like a big deal. I'm just popping those out and selling them. But like, I would not farm on anything lower than 8 terabytes.
All right. So going back to a few more of the follow-up questions we had to the new BladeBit stuff. Harold, is it going to have that extra 3% compression that we keep touting and talking about, but haven't quite yet released?
So the initial version won't have it. It's not yet finished, but we do plan on adding it in the future.
All right, cool. And another follow-up, are the larger K-size plots more than 2 times bigger because more entries means more matches and fewer drops? BladeBit with no drops are unnecessarily larger than ?
I don't understand the last part of that question, but the first part, yes, you have more entries proportionally to size, like we answered before, but I'm not sure what he means about the no drops.
There's a constant factor, and then you multiply by it's like k to the k to the 32 entry, like, sorry, 2 to the k entries, right? So you have a constant plus the exponential. So that's why a k equals 33 is just a little bit more than 2x bigger than a k equals 32, and a k equals 34 is a little bit bigger than 4x than a k equals 32. You have this constant factor, and that's why there's a little bit of variance, but it's a small constant. And by the way, all that's all in the proof of space construction document. I have a little spreadsheet somewhere where I calculate the hypothetical theoretical sizes for all the different k values. So
and about the part that he says BladeBit with no drops are unnecessarily larger than, I think maybe you misunderstood. No drops means, again, we truncate the current BladeBit because the addressable size is 32, so that fits neatly into 32 bytes, which just native to a processor. We drop those entries, but you should not, like, the reference implementation does not drop them. They're valid entries. Like JM said, they're negligible in size, but it's not something new that BladeBit's doing. It's just to keep in to make it compatible with ChiaPOS, we should not drop any entries. So that's what that means. It's nothing new.
All right. Most of this is going way over my head when we get into the plot files and the plotting stuff, so I'm just smiling and nodding. When we do the other AMAs and we do the other Q&As, I'm like, but when
plotting
this stuff, I'm just smiling, nod, just smile and wave, boy, smile and wave, because I just going right over my head. JM, have you spoken with any cloud providers since after the early launch conversations we had with folks like Backblaze and stuff? Have there been like future conversations or more recent conversations with folks in that space since the initial time?
We talked. As far as I know, this is actually near. So I'm writing a blog post right now that's about like the security of the network for storage, and we're basically doing the math and like, okay, so if you want a 51% attack the Chia network, okay, today you have to buy 35 exabytes. Okay, if you buy that in a short amount of time in plot involved, that's 600 million. If you buy it in a longer time, that's $1 billion. And doing that math, and people could make the argument like, okay, well, what about like these big hyperscale guys? These are the only guys in the world that have, arguably that could, already they have the purchasing ability to purchase 35 exabytes, right? Because if somebody wanted to buy 35 exabytes and went to WD or Seagate today and said, I have $5 billion, can I buy it? They'd be like, okay, we have to go build another factory. Sorry, it's going to take 2 years. It's just like, what are you going to do? Right? We're going to screw over Microsoft or Amazon. But these guys make an absurd amount of money on their cloud services. Just go look at S3s. They charge $15 per terabyte per month for an S3 bucket. And they replicate that data. They erasure code it and replicate it over 2 availability zones. But like $15 per terabyte per month, that's how much a disk costs. So they're making a whole lot more money monetizing that disk and selling it to people for cloud services than they are for anything Chia farming. If Chia farming, it's a free market, and I know Bram has been saying this since the beginning, which is like free markets get really competitive and really efficient. And I'll tell you, for my researching of Bitcoin mining this week, of like just how even competitive it's gotten since I wrote that blog post in October. The hash rate has gone up from 150 to 200 exahash. The price of Bitcoin has gone down from 68,000 to 38,000. Like Bitcoin is like almost even not, it's not profitable unless you have an S19. Like it's not even profitable unless you have the best, so this is just a way of saying like markets get really efficient and competitive. And so these cloud service providers will always have better, economics for monetizing their storage to cloud services and customers than they will for Chia farming. There will be some very short time periods, like the time period after we launched mainnet, and there was a very mismatch of net space and network difficulty to the price of the coin where it was insanely profitable to farm Chia. Well, what do you think happened? A bunch of people rushed out and bought hard drives to go fix that, and the net space grew exponentially to hit 30 exabytes. Now, the next time that price of Chia goes up very fast, we will see a net space expansion, and we'll probably see it a lot faster because there's a lot better plotting tools than we have today versus a year ago. Like a year ago, it took 20 hours to make a plot. Now it takes 4 minutes. So yeah, it's going to be it'll be interesting to see. But no, I have talked to a few of them. None of them are interested. None of the big guys are interested in like ever farming Chia. But the more we're talking, I am talking to the same guys about CDI and how we think about hardware reuse and circularity and what they do when they are replacing drives that are 3 to 5 years old. And again, these guys are replacing them mostly because they have such massive growing data demands that they have to get to the highest capacity, even across their hundreds of data centers across the globe, just to be able to make sure they have a competitive TCO and competitive capacity to basically accept their demands of their customers. So great opportunity for people that want to farm Chia. So
okay. Going back to some of the questions we have on Reddit that they were building up for us, there are some good ones in here. So here's one. Actually, we got two back to back. I'll go through. They're both sort of like internet randos, accepted truth yet highly debated type things that people want to kind of get some clarity on. So the first one is, do you have any insight on modifying hard drive firmware or settings to reduce power consumption and its actual effectiveness? For example, changing attributes like head parking frequency. Obviously, different drive models and different manufacturers require different approaches, but there's a lot of conflicting and information by people who feel very, very strongly about how true or isn't true some of these things are.
I've been begging WD to release the paper they wrote on this topic. It's just like any big company, there's always legal and complex stuff. But anyways, if you have a really high K value, so you have the number of plots per drive, N is very, very small, like 1 or 2, then you can get to the point where you can go like 10 to 30 minutes without accessing the drive after it's passing a plot filter. And so that's really good for that time period. Then you can go to this thing called idle B, where the hard drive basically parks the heads, and then you reduce the hard drive power by about 2 watts. But you can only do that about 600,000 times in the lifetime of the drive before that head starts to wear out. And then you start to get really tiny particles in the drive, and then those particles collide with the writer head, and then wow, you get data corruption and uncorrectable LBAs. And so then in these, when you have reallocated sectors, it starts really small, and then if you see reallocated sectors going up very, very fast, that means you have particles in the drive, and the drive's being destroyed. So can you do this? Yes, absolutely. But you need to actually pull it off, you need like giant K values. Like you need 1 or 2 plots per drive, and it's really, really tough on large capacity drives. Spinning down the drive, I mentioned, if you have a load unload cycle, if a hard drive is rated for 600,000 of those in the lifetime, it's rated for far, far fewer actual hard power cycles on and off. Now, when you power up a hard drive, it takes 10 seconds for the motor to power up and spin up, and you have inrush current where you have higher power for a shorter amount of time. And so in that 28 seconds you have, right, to go be spinning up every drive every 30 minutes and then spinning them down and spinning them up, that's really, really bad. So a more practical solution would be a future farming drive that has very low RPMs and does that idle B, where it can easily park the heads and go off and do IO, because the drive in farming is idle 99.7% of the time. But an even better solution is once in 5 years from now, when we have high capacity SSDs that are really cost competitive, to hard drive storage, where they can farm at 0 power, because SSDs have no problem completely turning off. Like your phone does it your phone, your laptop, everything. When you shut your lid, the SSD completely turns off and it retains some state in memory. And then when you pull it back up, voila, you can do IO to the drive within 10 microseconds. And then a full hibernate is like 100 millisecond resume time, which is totally good for Chia farming. So it's for hard drives. There's no magic bullet. With the hardware that's out there today, I would recommend that people not try this because, and if anybody wants to see the math, I'm happy, we'll share that. But it's almost impossible to tune the drive because, okay, remember, so the drive is idle most of the time, but it's being accessed very frequently every 10 to 30 seconds because of one plot statistically, one plot is going to pass the filter, very, very frequently when you have hundreds of plots of the drives. So yeah, you really can't spin the drive down. So now you want the drive with the lowest idle power and the highest capacity to get the best farming efficiency. So.
Okay.
That was a long answer to an easy question. Which is like, don't
I mean,
this. It is possible.
That's the whole point of this, is to get that context. All right. Also, real quick before I go to the next one, this popped up in the YouTube chat, and this has become a running joke across all live streams, so I wanted to mention it. Someone commented, "I'm really glad to see you got a better mic now, finally." Funny thing, no, I didn't. The other location I stream at, this is a different mic from that stream, but this is the same mic I've always used at this location. The difference is I now have a pop filter in front of it, and it's on a shock mount. Other than that, I just unplugged the USB cable and plugged in an XLR cable into a USB adapter. But functionally, it's the same mic. It just holds true that I can't do anything right. You all are going to always have comments about it being better than it was before or really bad, when actually nothing ever changes. I am just doomed. I'm just doomed. So I do have
you brought this on yourself, Jay.
Yeah. Now the other location, my main home office location, that mic is now changed to match this one, however. But the only thing is I switched it to XLR. That's all I did. Anyways, so the follow-up to the community kind of not really urban legend, like myth, not myth. What do you call those things? The wives' tales, those kind of stuff. Those kind of conversations. There is, it has been almost universally claimed, parenthetical, by random internet users, that a 3.5-inch USB hard drive powered by a wall wart is less energy efficient than running that exact same drive bare in the system powered by standard PC power supplies. Let's say gold-rated ones, he says, for this example, or they say. Their personal belief is any difference would be incredibly marginal, if at all, as modern wall warts are very efficient anyways. Do you have any experience or data on that difference?
No, it's easy to measure, though, right? I can go grab an external and measure it today. I've done them, but if you just look at the first principles, if you have a drive that's talking SATA and you put a SATA to USB adapter, even if that chip is half a watt or a quarter of a watt, and then you have a power adapter that's 90% efficient, you will never have a USB hard drive that is more efficient than a SATA drive, because they take the SATA drive. Anybody who's ever shucked the drive knows they put the SATA drive in the USB enclosure. There is no USB native static, or USB native hard drive controller. So you will never, ever, and I can say this with absolute certainty, have a USB hard drive that is more efficient than a SATA hard drive, period. Now, on the spec sheet, you might see some, there's a lot of, now the one thing people might know is that most internal hard drives, SATA hard drives, are 7,200 RPM. It is very rare. There's almost no high capacity SATA HDDs today that are sold at 5,400 RPM. So, but the 8 terabyte drives, like Seagate has an 8 terabyte drive that's 5,400 RPM. That is a host or drive managed SMR, and that's actually one of their cheaper drives, like 115 bucks or something for an 8 terabyte drive. That's actually pretty power efficient. That's like almost 3 watts for Chia farming, whereas a standard 7,200 RPM high capacity SATA drive is 5.7 watts or 5.6 watts. So yeah, the only thing I could think of is maybe you get about a watt better on these USBs if they take these drives and spin them down to 5,400 RPMs. Now I won't tell you, I won't tell you why that's not true for the power, but I'll just tell you that you're not going to get better power in the externals because of the method that they use to slow down that drive is not going to reduce the power. And I know I'm not going to give away the hard drive manufacturer's secret there, but I know how they do it. It's not going to reduce the power.
All right. So along the lines of that power subject, actually no, we covered that one earlier, so never mind. Don't have to follow back on that. So there's a question I'm gonna read, but this actually feeds into that. So I'm gonna start with this one first. Someone goes, I remember, unless I'm mistaken, that Gene has mentioned in the past about eventually adding file storage abilities to plot files, and no, he did not. You're remembering wrong. This is a question we are asked almost every single AMA and every live stream about storage is, why do we do it, or why don't we do it? When are we doing it? No, we have a very strong philosophy on not adding file storage to plot files for a reason. I'm not going to go down that rabbit hole right now.
Yeah, they may have been confused with something they said, which is like maybe we'll have a shim layer that allows you to have the plots underneath the file system, and then the host OS only sees the file system with real files, and then there's a harvester that looks at the shim layer and says, okay, I'm going to look for all the plots available in the shim layer, and just farm those. Now that works really good on a hard drive. It's terrible for SSDs
Yeah.
because
But
SSDs need that free space to function for over provisioning and garbage collection. And if you just like take up all an SSD space with plots and then try to only use a small amount of user data, the performance
yeah,
is going to be really bad.
but
And
but
that's one. Yeah, that's one of these problems I have to solve with the SSD vendors in the next couple of years about how we do that for farming efficiently. But for hard drives, it's totally possible. But the more practical thing is just like file systems are pretty good at storing files.
yeah,
If you take a hard drive ext4 full of plots and delete them, that deletion takes, I don't know, 30 seconds. If you format the drive, it'll take 5 seconds. So yeah, deleting files is slightly slower than formatting, but it works.
yeah. But to the point of the question, we are not looking at adding file storage
Yeah,
capabilities to plots.
yeah.
No,
But you
and
can totally have a drive. You can totally have a hard drive that has some user data on it and some plots on it. That's totally legal and happy.
and that leads into the question of people asking, are there related to plotting and storage questions that we've been repeatedly asked over and over and over again over the last year that you really feel that everyone should know the answer to by now, and that you really want to just kind of hammer home one last time? That's the question that I'm actually getting to that led into.
Well, I've seen a lot of nonsense on. Okay, so for Chia plotting, right? Okay, I went out there in the beginning and said, okay, guys, data center, you guys are looking for a drive that has high sustained write bandwidth and good endurance. Like we already have those. They're called data center SSDs. Like you don't have to invent a new drive. You already have one. You have data center drives. And so people are finding now, okay, you can buy a consumer drive, and there's different consumer NVMe manufacturers like use a different calculation to calculate their total TBW, which is unfortunate, but people are finding, okay, I can run the drive maybe 3 to 5 times longer than the TBW on the spec sheet. That's good. Okay, well, the NAND on those consumer drives is rated for about 3,000 cycles. The NAND on enterprise drives is usually rated about 10,000 cycles. So no matter what, you're going to at least see 3x endurance, but often you'll see like maybe 3 to 5x endurance, sometimes even 10x endurance on a data center SSD versus consumer SSD. And you can find used drives in any form factor you want on eBay for the same price as like a high-end NVMe. So people like that's the one thing that people are like, no, you don't wear out drives, so just buy a consumer drive. Like that's not the point. Like even if you're plotting 200 terabytes and you don't care about using up the endurance in a $200 drive, you could buy a $200 enterprise drive that could plot 3 to 5 times more, have the same performance. And if that's what you're doing, then that's a better purchase for you. So anyway, and I'll get off my soapbox, but I really do like data center drives for plotting, and anybody who has used one knows why.
All right. Let's see here. Oh, I lost my Q&A box. Let's get that back. Where'd it go? Here it is, Q&A box. Oh, let's see here. Got it.
Yeah, we can stay for another. Should we stay for an extra few minutes after?
Yeah, so we've got. I for some reason I thought it was 10 till. It's actually 3 till. I somehow can't read a clock. So I was gonna kind of squeeze in like 3 or 4 questions. There isn't any more that I saw you guys had tagged. Actually, no, Harold tagged a few. I'll go
Harold's
through.
Harold's doing his job in tagging questions.
Yeah, Harold is doing what I asked.
I am
JM
not.
is not, which is I thought JM was my bro, but yeah. So let's see here. Let's get some of the ones Harold wanted to cover. Harold, I'm a big fan of BladeBit, but I'm still running this on half of my CPU on WSL due to performance. Will the Windows edition get more love now that it's backed and funded by Chia?
So Windows is definitely supported. There's always going to be some performance difference. Even in different Linux distros, we get massive performance difference in memory. So memory writes and reads. So for example, on BladeBit, the fastest one by far is Red Hat Linux-based distro. So CentOS, Amazon Linux 2, or probably even Rocky, though I haven't tested, run way faster than Debian-based ones. And Windows, we have that same issue where just for some reason memory is slower. And one of them, I remember reading an article, there's something Windows 10 enabled by default that you actually have to disable in safe mode that actually causes memory bandwidth to be much slower. So that's probably related to that. We don't really do anything different in Windows as opposed to Linux. So we're just basically pushing all the memory bandwidth we can. So it's at that point, it's unless there anything new that we can change on our side without asking the users to disable something in the OS, it's definitely going to be supported, and we're going to do everything we can to make it fast, the fastest we can there.
All right. JM, what sort of drive capacities do you expect to see from the CDI become available to users like us?
Yeah, we'll just say we talked to the refurbished drive sellers and stuff pretty frequently. So right now, the hyperscalers are all getting rid of their 10 terabytes and 12 terabyte drives. So there's a lot of 10 and 12 terabytes coming in. So that's what I've seen mostly. There's also some 16 terabytes, but those are probably more on the refurbished side, not like the used side. So yeah, right now I see a lot of 10 and 12 terabytes, which if you get a 12 terabyte drive at $10 per terabyte, that is a better TCO than even a $300 18 terabyte disk. So that's a good deal. So anyways, we'll see how, but those are what I'm seeing right now.
All right, and another one for you is Akash meant to be the plotting solution for pre-plotted drives from hard drive manufacturers? Like, should they be able to kind of tap into that network and get their?
No, I wanted to talk about that a little bit more, and I have a YouTube that I posted on my personal YouTube on just kind of how to do the Akash thing. So people should check that out. I'm providing really cheap plots right now for people that want to do this plotting as a service. I think I was doing 3 cents or 7 cents a plot. I think realistically it'll go to about 20 to 30 cents a plot. So I think that's a good margin for the plotting provider, as well as a good price for people that want to buy plots and don't want to buy plotters. But ideally, if there's Akash scales and we have a ton of people in the community that have higher end plotters that are more idle and they want to monetize this, and then we have hundreds of systems online that can plot, that will be really easy for a hard drive manufacturer. One of the ideas I came up with that we're trying to pitch is, because actually plotting the drives in the factory has been really challenging, just because changing anything in a large scale factory that's in production is extremely hard. But they could easily offer a coupon or a ticket that says, okay, well, you bought an 18 terabyte drives and it comes with 8 terabytes of plots. You can go put in this code and this website and download. And that website could use Akash on the back end to go download the plots, fill it up. There's some checks you have to do to basically say, okay, do you have high speed internet? Yes. People are finding out, oh my God, I tried to download a plot and it took an hour. It's a 100 gigabyte file. It's a lot of data. I don't know what to tell you. So, it's not going to work for everybody, but, for some people that don't have, there's a lot of people that have fiber internet, but or have, high download speeds, but do not have a plotting machine. Even though really all you need to plot is a desktop plus $100 SSD, but a lot of people don't have that. So, I think this is going to be a cool solution for them to basically offer pre-plotted drives. Maybe they do that through Akash or a coupon or something like that. Maybe they just, but we're figuring that out. So.
All right, Harold, how's the chain actually know what size plot produced a given block?
So more technically, I think this is a question that Bram or Mariano can answer more deeply, but the case size is stored in the plot file. So whenever you do a verification or anything, you actually need to know the case size in order to either prove or verify. So you just pull the case size from the plot file.
Yeah, and this has to be done because there's literally a line of code that says, if you are less than k equals 32, disqualify you. Because on Chia mainnet, we have k under k equals 32 is not allowed on the network. So, and if we ever wanted to reduce that would be a hard fork. But if we can go the other way without hard forking. So that was something I learned from Gene the other day, that eventually, in 10 years from now, if we need to phase in k equals 33, then we could do it with a soft fork and not a hard fork. But we are not doing that anytime soon. So
and I was about to say, I'd like to.
32 is totally fine.
I was just gonna say, I'd like to point out that you just casually said, eventually, if say 10 years from now, that you did say if say 10 years from now, because one of the questions in Reddit was, people still keep coming back to it's very clear K33 is going to be required within the next 1 to 2 years. What do you think about that? And the answer is, we don't agree with that statement. We still don't agree with that statement. Everyone keeps saying that, but we don't know where it's coming from.
K equals 32, but no, realistically, we're doing plotting research on k equals 32 to make sure we know the fastest plot time. I think Harold's fastest plot time is 220 seconds, around there. My fastest bare metal plot time is 230 seconds. We're looking at that on, PCIe Gen 5 and DDR5 and next gen. Okay, and we expect to maybe see a 20 to 30% reduction. There's some questions. Harold and I have been talking a lot about the new Mac announcement, and when you have unified memory that's high capacity, that has a GPU attached to CPU and big unified memory, that's actually really cool for plotting, because you can do some of the sorting theoretically in the GPU, but you can't move that data fast enough back to host memory and back to the GPU and back to host memory and back to the disk. It's never going to be fast enough, to beat what in-memory plot today is with Blaebit. But anyways, this is really cool stuff that Harold and I talk about all day, just because we love to geek out on this stuff.
Yeah, and even if you can manage to get a phase one within 30 seconds, it's just not practical anyway. It takes so much computing power to even get it down there. Like right now, we're hitting can't remember phase one times, but like JM said, so 200 something seconds.
120 seconds or so, or 100 seconds for phase one.
Right, and then
so it needs
once
to be,
you get.
Oh yeah, go ahead.
Yeah, no, just saying, once you get down to that times, it's really hard to reduce. So when you reduce, maybe you reduce 5 seconds. It's really hard to say out of nowhere reduce 30 seconds or something like that, unless we have a big change in hardware or something like that. Like JM said, maybe we can. We'll see once we start testing with the new Mac to see if actually sorting is as fast as we expect it to be. But even then, just make a plot in 5 minutes. It's way cheaper.
All right. Another question here, and we'll do maybe 2 or 3 more. Everyone knows we all love us nerds love our data and our graphing and our charting. I use Grafana extensively for my home lab. Chia Monitor, Chia-Monitor, really, really great project that I love to use. It does some really great graphing through Prometheus and Grafana for me. We've talked before about adding some of that stuff in natively to a few things like nodes and a few other stuff, but they've asked, is there any chance we'll be creating any kind of dashboards that are, pre-built dashboards or pre-built data collection specifically for plotting, monitoring, and charting and tracking?
Yeah, for plotting, monitoring, and anybody who's seen any of my personal YouTubes, I use Node Exporter with Grafana and Prometheus. And I think out of the box, like that's the easiest one, where you just install all 3. And I know I'll do a video on how to install that, because I know there's you Google how to install that, and there's 100 different, Linux people, right? There's 100 different ways to install it. So there's 100 different, pages on how to install it. But that's a good one out of the box, where when you're plotting, you want to know your CPU utilization, you want to know your IO weight, you want to know your disk bandwidth, you want to know your temperature of your CPU and all the components, and you want to know the frequency of the CPU. If you know all those and you can see them in real time on the dashboard, you can know, okay, I made a plot in 25 minutes. Okay, well, I was only using 30% of my CPU. That means that system is theoretically able to do 3 times more plotting output than the plot time you just gave it, right? So that's a really cool, useful tool that I use basically just out of the box to basically understand the plotting. Now, I think I want to say that Kyle, who's been working on Plotman, the development for Plotman, he has some stuff in there where you can already export some of the Plotman stuff to Grafana, and it basically shows you when plots are in what phase or whatever. I usually just, you can see the CPU go from 80% down to 30%. It's very easy to see when you're in different phases, from Grafana. But yeah, we could do that too. So yes, yeah, we should. I'll do a video on how to set up the resources that are already out there to be useful for plotting. But then we have some other stuff that's built in for plotting, but I'm not sure. I'll have to check on where it's at.
All right. I'll if you guys want, I'll let you each pick one question we haven't gotten to that you really want to answer, and then we can just wrap up on those last 2. If you guys each have a particular one that you're have wanted to answer but I haven't gotten to yet, because unfortunately we have a lot more questions than we have time left. So
yeah, there was a question that I think is near and dear to my heart too, right? Because I'm a large farmer, which is okay, so you do all this stuff for CDI, and that theoretically should lower the cost of disks, for using second use drives for Chia farming instead of brand new drives, and wouldn't that expand the net space? And that would hurt farming profitability. I mentioned, again, Bram has warned everybody, and unfortunately, farming is a free market and it's going to be ultra competitive. Now, it happens today that farming is actually more profitable than Bitcoin mining as of today, as of 3/11/22. I just did the analysis this morning for a presentation that we're doing next week. But so as grim as it sounds, compared to farming profitability, right after mainnet launch, who knows? I expect when farming gets very profitable, people will rush out and buy storage. We have a net space model that we use that I've created that is based on price. And when the price goes up very fast, people will rush out to buy storage. We saw the same thing with Ethereum and graphics cards. When Ethereum price was very hard. High GPU prices were sky high, and unfortunately that remained for many years. And when the price goes down low, we'll see the opposite. We'll see the market flooded with used hardware. So, will it affect the profitability? Well, the way that we're going to be able to grow sustainably is in these periods of time where the price is going up slowly and the net space will expand. If these second use drives are available, then Chia net space will be able to absorb those into the net space, and the net space will grow. We would rather have that future than a future where those price spikes and it's very volatile and people are rushing out to buy new drives, and then those people aren't like long-term farmers. These are people who are just trying to arbitrage the price and make a quick buck, and then they're trying to sell the hard drives or flip them or whatever. We don't want those people in the community. We want people that are farming, that are going to be in it for the long run and are going to be stable for the network. I mean, you've seen, right? The price has gone down and the net space has been relatively inelastic, which means we have people are committed. They put the plots on the drives and they realize that it's very low energy to keep them on, and they're not turning them off because it's still profitable, because the energy use for farming is still lower than the income and revenue that they're earning for that farming. So that's a long way of saying, it's an ultra competitive market. We want to grow sustainably, and we're doing everything we can to make that happen. For people that want to buy and want to participate in the CDI and want to participate in using this used storage and get the best cost storage and be the most competitive for farming, we're going to help hook those people up. And I will hook those people up today if they want. We're do everything we can in our power to not make it disadvantaged for people that they're like, well, I only have access to Amazon. I don't want to be disadvantaged because I'm a farmer and I can only buy drives at retail price. Well, it's a really competitive market, and used drives are really good for Chia farming. And over time, new drives will not be competitive for Chia farming. I'm just going to say that now.
All right. What about you, Harold? Got one that you want to cover?
Yeah, I'll answer this one, which is asking if the new plotter will scale more linearly with more threads, comparing it to Mad Max, where you have to start using multiple instances at some point. It makes really good use of threads. So it's linear up to the point that your memory is just and your CPU is way faster than your disk. So your disk is much slower than memory. And like I showed earlier, we hide the reads and writes in the background. But if your computer is just too fast for that, for your disk, at some point you just have to stop giving it too many threads, because you're going to stall and start waiting for the disk to finish reading a file or finish writing a file. So we'll be sharing tests once we're at that point where we're using how many threads, how much can you max it out in the threads versus the type of storage that you're using. And the preliminary ones were pretty good. You can throw a lot of threads at it, but again, you're always going to be bottlenecked by disk at some point.
All right. One last thing I learned, because a Twitter thread happened while we were doing all this. I was not aware that Harold's Twitter name was garlic broccoli, which is awesome. That sounds delicious. And I just wanted to share that because that's amazing and I had no idea. That is unexpectedly unique. Anyways, aside from all that, thanks guys for doing this today. Most of our Q&As that aren't open at an AMA tend to be focused on like product releases or new features and stuff. It's fun doing one on a more generalized but very interesting yet slightly focused topic like storage, especially because storage and plotting is something that I think a lot of people have a lot of questions that are interested in, less so than it was, I'd say, a year ago around this time. Plotting was basically, all anyone could talk about and how to optimize and min-max every last second of it. Now people are more into a business as usual mindset. And I think people like having a chance to talk about these kinds of things. We haven't really made it forefront in a while. So we should do these a bit more regularly, maybe not as often as we do our AMAs, but definitely go more than I think it's been the 6 months we've gone since the last time we've had a conversation about this.
I did see a lot of good questions about SSDs and trim and all kinds of fun stuff in the chat we didn't have a chance to answer. So I'll just go into the plotting channel. I'll answer those. And they're great questions for the community. And I was talking to one of the community members the other day, and they're like, "Oh, I didn't want to bug you." I was like, "Yeah, you're like obviously investing a lot of money in Chia plotting. Like you should, ask me about some of this stuff." And he was like, "I didn't want to bug you or whatever." No, go to the plotting channel, come bug us. It's great. We love talking about. If somebody says like, "I have $500. I don't want to buy a plotter. What should I buy? I have this machine. What SSD should I buy? Like we love that stuff. Just come to the plotting channel. We'll hook you up.
Yeah, and I'm telling you all right now, bug him. Like, he's not doing anything good with his free time. Like, I know what he does in his free time. His free time is spent playing this garbage game called League of Legends made by Deviants. Inside joke, I worked there for many, many years. But he's just playing League of Legends in his free time. So, feel free to bother him. It's just, yeah, he's got nothing better to do at this time. Anyways, thanks guys for doing this. Thanks everybody for coming. We're going to see you all relatively soon with our next actual live AMA. As we've announced on Monday the 21st, we're going to do a AMA to celebrate the 1-year anniversary of the launch of our mainnet, which is on the 19th, so next Saturday, a week from tomorrow. We're not doing the AMA on the 19th itself because Saturday afternoon's a really hard time for us to organize an AMA, and it gets kind of messy with time zones and people's availabilities and that kind of stuff. So we're gonna do it on Monday the 21st instead. However, we're also going to do after the anniversary AMA on the 21st, later that following week, I'm also going to do a live AMA, like all day long thread on Reddit. So if you have a question that isn't covered in our big extravaganza anniversary AMA on the 21st that we don't get to, or you think of a question as a follow-up after or whatever, we're going to have a Reddit AMA probably maybe Wednesday or so, depending on timing, where we'll kind of have people answering questions all day long. So you kind of have time to put questions in and get answers later on. So we're going to do both a written and a live one in a week and a half, 2 weeks. So we'll see you all then for that. Thanks for everybody for coming. This was a lot of fun. Always are. So we'll see you all next time.
See everybody.
Yeah, thanks again, guys.